So as for today, we're going to discuss this method. If we have not enough time, then you can proceed with the same method on Wednesday. But let's start with this first. Okay, so our next method in optimization is Hooke and Jeeves. All right. So remember, we still in our direct search method. Okay, we have what? We have the first one is Fibonacci. Okay, and then we have golden search method. All right, and then we have the interpolation method where it is quadratic and also the cubic. Okay, now still in our direct search, okay, but dimensional search method. All right, so we are still focusing on a direct search method, but for this Hooke and Jeeves, it is n-dimensional search method. All right, so remember in Fibonacci, you just search directly from the interval. Okay, let's just recap. You just search directly from the interval where you have to calculate L2 and you have to identify the number of iteration through the Fibonacci number. In golden search method, you search through the interval, but the interval has the value constant of tau. Okay, so we proceed with the same exact value at each iteration by using the tau value. Okay, and then for interpolation, we still focusing on search method, direct search method, but on quadratic and also cubic approach. Okay, so now for Hooke and Jeeves method, it is focused on n-dimensional search method where we still focus on a direct search method, but we have some sort of pattern search method. Okay, so in order to implement the n-dimensional search method, we use the pattern search method approach. Okay, all right, so let's take a look at this. In Hooke and Jeeves, all right, still we have direct search method, right? So we are going to use base point. In this Hooke and Jeeves, we are going to use this base point, okay, and the step length of H. B is our base point. H is our step length in the direction of EJ. So usually the direction is in terms of unit vector. For every variable of xj, where j from 1 to n, okay? You know, EJ is a unit vector. So usually in our calculation, we don't use this EJ because EJ is a unit vector. Whatever multiplied by a unit vector will get the value back. Okay, just for the direction of the x-axis. Okay, so we are going to evaluate FB and continue with the exploration move and the pattern move. So we are going to explore the move. We are going to explore the movement from the base point by using the length step of HG. Right? Is that clear? The idea here is we are going to explore, okay, and it is explored. The movement is explored by a pattern. Okay, how can we explore? We should start with our base point with a length step. Okay, and then for the exploration move, if the value of fx is reduced, okay, remember we're focusing on minimization. Then if the value is reduced, then we obtain a successful movement. All right, because we focus on minimization, if the value is reduced, then it's considered as a success movement. Okay, not a success extremizing, but just a success movement. Whereas if fx is increased, means that no minimization occurred, then we obtain a failure. The exploration move is to acquire knowledge about the local behavior. So we explore here in order to just locate our local behavior of the function. Okay, we just want to move towards the minimizer, towards the minimum value. Is that clear? Clear now? So this knowledge is used to find a likely direction for the pattern move by which it is hoped to obtain an even greater reduction. Because why? Because we want to minimize the function. Okay, clear? We move, we explore by using a pattern, okay, starting with our base point with a length step of hj. Why? Because we want to have greater reduction. So once the function reduced, then success. Once the function increased, then failure. Okay? Then the pattern move does not determine the success. Right? Remember, this is just the movement to locate our local behavior of the function. So the pattern does not determine the success and the failure of the movement. So it just used to accelerate the search by using the information. Okay. So how is the movement? All right. So how can we move the base point here? So let's say we have our point, we have our base point here. Okay. Then we move towards with this is your first point. We move toward the second point. Okay. When it is reduced, then we say that it is what? What? When the function or the value is reduced, then we say that it is a success or a failure movement. Success. Right? Okay. Um, before that, sorry. The movement process, okay, is always from right, okay, to left to upside and to downside. So this is how we move. Okay. So let's start again. First, this is our first point. Okay. Right. Then we move to the right in our next point. Okay. And then if it is success, okay, if it is success, then no need to move to the left. Okay. Then we just go upside. Okay. Let's say this is failure because why? Because increase value means failure. So we move downside. No, this is the, okay. And then this is success. Okay. Now evaluate FB1 and continue with the exploration move and the pattern. So in terms of pattern, it moves like this. Then this is our new base. Again, we move to the right, and if it is success, try move to the upside, and if it is failure, we move again. Then this is our new base. So this is success. Okay, it is not always like this, but this is how we move. Understand or not? Any question? Then let's say the iteration is not fulfilled the stopping criteria again. This is our new base. Okay, and then we move again. Okay, and then from right, let's say it is failure. Then you have to move to the left. Okay. Let's say this is also failure. Then we have to move to the upside here. And then let's say you move downside and then it is success. Okay, so this is how we move. Clear now? This success or failure should be determined by the value of f. Okay, it is not always like this pattern. Okay, the success and failure here is decided by the function value. All right, once you use the point there. So how it move actually? How it move? Okay, let's say this is the new base is 0, 0 and step length h here equals to 1. So means that it move one step. So here is what? 1, 0. Okay, and then another movement, one step. Here is what? Maybe 1, 1. Here is 1. Right. So this is how we move. Okay, any question for this movement process? Understand or not? Clear? All right, good. Okay, so next. So this is how we explain here. The new base 4 here, okay, is obtained when f4 less than f1. So this is your b1, this is your b2, okay? Your new base 4 is obtained when f4 less than f1, okay, by exploration move where 3 fail, 2 success, 2 and 4 success, okay? Then the point 5 is obtained by the pattern move. So this is pattern move, right? The exploration move is from what? The exploration move is from base to base. B1 to new base, B2. Okay, and then the point 5 is obtained by the pattern move. So pattern move is from point to point. Okay, from 5, we make an exploration move again. Okay, understand or not? We make an exploration and then 8 here is our new base where f8 less than f4. This is your new base. Okay, then the point 9 is obtained by a pattern move from 9. The point 13 is obtained from the exploration move, but it is not accepted as a base if we assume that f13 greater than f8. So maybe somehow here there is a condition that there will be no change within the base. So somehow it is f13 greater than f8. Okay, that one, let's check the example after this. Then we go back to base 8, which will be our initial base, and start again with a reduced deadline. So this is the condition. If there is no success in that certain move, okay, means that you have to turn again to the latest base by using a reduced step length. So initially our step length is 1. Maybe we just can reduce half of it, 0.5 and so on. Okay, clear? So this is the explanation of this movement. Any question? Everything's good? Okay, so let's try to understand this algorithm by using the example. We do it all together. Okay, so now let's take a look. Our first step is to choose an initial base, right? What is our new base here? What is our base here? No one want to try? This one? Yes, it is 0, 0. Okay, so this is the example that we're going to use to discuss this algorithm. Okay, so you should compare this algorithm together with this example. So first you choose your base. Base point here is given as V1 and the start length Hj for each variable of xj. So it is given here H1 equals to H2 which is equals to 1. Alright, there is no symbol here. Okay, and then we should stop when H1 or H2 less than 1 over 5. So this is your stopping criteria. So where can we start? Okay, so now how many variables involved? There are 2 variables. So we should start with the exploration step. Okay, from B1. Okay, and then we need to evaluate B1. Okay, so let's use a table. Okay, the first evaluation we need to start with our base point. So 0, 0. So when x1, x2 are all 0, f1, f equals to 0. Just substitute the value here to the function. Okay. Okay, and then the next exploration. We should start with what? Remember our movement process is from what? Let's say this is your nampak tak? Can you see it? Or is it too small? Can you see it clearly here? Is it too small? Can, right? Okay. So we should start with our base. So this is your base. Okay, now we always move from right to left to upside to downside. So now from right to the right, to the right with h equals to 1. What is your next evaluation? What is the next evaluation point here? Okay, 1, 0. So, okay, understand this. Now, your next evaluation point, 1, 0. So, when x1 equals to 1, x2 equals to 0, what is your f here? Seven, right? So 7 is considered as a fail or success. You start at 0, 0. So 7 means upside, right? So 7 is success or fail? Okay, fail. All right, so when it is fail, then what should we do next? What is our next evaluation? Where is our movement? Downside, upside. Here, the movement process, right to left to upside to downside. So next is to the left. Okay, what is our new point here to the left with h equals to 1. Okay, so minus 1, 0. All right, so our next evaluation is minus 1, 0. What is our f? F is minus 1. So from 0, 0 here, minus 1 is downside, right? Consider it as a success. So when it is success, then we go upside. Okay, the movement process is always like that, to the right, to the left, upside and downside. So upside, what should be your new point here? From minus 1, 0, step upside about 1, then it will become minus 1, 1. Okay, so your next evaluation is minus 1, 1, where the function equals to 5. Is it 5 or 2? 5, right? Okay, so when 5, consider it as a failure or success? Okay, good. Fail. Then again, move downside. So your new evaluation is from point, yes, minus 1 and minus 1. Okay, settle with the movement. Exploration move complete in this iteration by using the 0, 0 base. So this is your evaluation in the first calculation, in the first iteration here. So as you can see, which point is the most maximum, the minimum? Which value of function is the most minimum? Because this is minimized function, right? It is minus 5 here, right? Okay. Then what can you conclude? Okay, take a look at the algorithm. We start with base, H, carry out an exploration about B1. So we have done this exploration. This is exploration move. So the exploration about B1 proceed, evaluate FB1. So we evaluate FB1 already. Each variable now is changed in turn. So how can it change? By the movement process in evaluation, in exploration mode, by adding the step line. Okay, by adding the step line, then we evaluate this one. This one is what? This is F00. FB1 plus H1, this one is F10. If this reduce the function, replaced by B1, okay? If this reduce the function, replaced by B1, okay? Initially, it is 0, and then it is 7. It is not reduced, right? It is not reduced. It is increased. Then we replace, but if not, find B1 minus H1. That's why we step to the left and replace by B1 minus H1. Okay, if the function is reduced, then consider it as a success. So from 0, now it is minus 1, then it is reduced, so success. Again, we repeat the process. Okay, make the same step. When we have considered all n variables, we will have a new base point. So we consider all n variables means we complete all steps. Okay, so that's why this is our new base point. Okay, this is your P2, new base point, which is B2 equals to minus 1 to minus 1. Okay, If B2 equals to B1, then we should make some adjustment in the step length, right? By reduce the step length. Now, if B2 does not equals to B1, so now we have B1 0 0, B2 minus 1 minus 1. So B2 does not equals to B1. So we make a pattern move from B2. So now from this B2 minus 1 1 minus 1 minus 1 here, okay, this is your B1, this is your B2. All right, we have done with the exploration move. Now we want to make a pattern move from B2. Okay, how can we make a pattern move from B2? By using this. Okay, so for if B2 does not equals to B1, we make a pattern move from B2 where the pattern move is indicated by PI. BI plus 2, BI plus 1 minus BI. So our pattern move from B2 is given by B1, BI equals to B1 plus 2, B2 minus B1. Okay, your B1 is 0, 0 plus 2, B2 is minus 1, minus 1, minus 0, 0. Okay, so this is how you obtain the pattern move, which is here equals to minus 2, minus 2. Okay, where FP1 is minus 6. Okay, now we should explore again. Okay, we should explore again. Exploration step, your next exploration step. So now it is moved to, this one is minus 1, minus 1. It is moved to minus 2, minus 2. Okay, so as you can see here, this is the exploration move. This is the pattern move. Next, from this pattern move, okay, from this new base of minus 2, minus 2, we should have our pattern move again. We should explore. So our next exploration step must start from P1 now. Okay, understand or not? Okay, so your next evaluation, again, we should use this table in order to ease our calculation. All right, we stop our exploration in the previous step at 5. So the next evaluation is 6. Okay, clear now? So now this is negative 2. Okay, negative 2, negative 2. Okay, we move to the right. We move to the right with a step length of h. What is our next point? Yes, minus 1, minus 2. Okay. The evaluation is for exploration. All right. So the pattern move just a starting point here, not our base. Okay. So now what is the f minus 1 minus 2 here? So fp1 is minus 6. Now you have f x1, x2 minus 7. It is reduced or increased from the previous function. Reduced, then we consider it as a success. Okay, when success, okay, just like before, when success, right, no need to move to the left. This one we start with B here, then it is failure, then we move to the left. Now it is success already, so we just move to the upside here. We move upside. So this one is -1, -2. So what is our next evaluation point? -1, -1. So what is our function? Function value -5. Okay. All right. So this is F or S, fail or success. Okay. Fail. Why fail? Increase from what? From the FB1 here. This one. FB1 lah. FB1. If the function is reduced. Okay. Now, this is failure. Okay, then we should move again downside. So what is our next exploration point here? Should be -1, -3. Okay, so this one -1, -3 will give you minus -7, right? Okay, this is considered success or failure. Okay, success. Actually, it is not success, it is not failure because we have obtained -7 here. Okay, so we just take this, all right? We don't want more exploration. Then we just take the value here for the first success, then we just consider this as a failure. All right, so now our next base point is what? Our new base point is B3, which equals to what? -1, -2. Okay, where FB3 equals to -7. All right, clear now up to this point? Any question? Alright, anyone has question before we go further? Right, so now we stop at H1 or H2 less than 1/4. So up to the point here, our step length is still 1. It is not reduced yet. So we just proceed with the same process again and again until we reach H1 or H2 less than 1/4. How can this H1, H2 is reduced? When B2 equals to B1. When we obtain the same value of the previous base point and the new base point. Because when we obtain B2 equals to B1 or B3 equals to B2 or B4 equals to B3 means that there is no function reduction. Then the exploration is repeated about the same point with a reduced time length. So we have to check. Okay, next. Now we have our new base point. What should we do next? Okay, we should have what? Hmm? What is our next step from here? We should evaluate our new pattern move. Okay, good. So we should evaluate our new pattern move. Now it moved from B3. Okay. So pattern move here B2 plus 2, B3 minus B2. Same formula with this. Okay. So we have our B2, which is what? Our B2 here is minus 1 plus with 2. B3 here is minus 1 2 minus 1. Then we should have our P3 or P2? P2, right? P2. P2 equals to minus 1 minus 3. Okay, where FP2 here is minus 7. All right, then proceed. We don't have enough time, but at least I want to show you up until reduce step length. Okay. Okay, now you understand, you can go faster. So what is our next exploration step? So next exploration step start from P2 now, okay, which is minus 1 minus 3. So our new evaluation start where? Start at where? So the next evaluation is 9x. Okay, so this is our point, minus 1 minus 3. Okay. So to the right, what is our new point? Remember, our start length is still 1. So we move to the right first, about 1 step. It is 0 minus 3, right? Minus 1 plus 1, 0. Right? Is it 0 minus 3? Why you said minus 1 minus 2 here? If it is minus 1 minus 2, means that the movement is upside. Remember, we should always start with from right to left, upside and downside. Clear not? Okay, understand or not? Why it is 0 minus 3? Okay, so our new evaluation start from 0 minus 3. Okay, right, remember, this is the main important point, the movement process. Okay, first step, second step, third step, fourth step. All right, you proceed with the step when you obtain failure. Okay, from right, okay, this is your point, right? You move to the right, then fail, then you move to the left. Okay, then let's say this is success, then you move to the you move upside. Then let's say this is fail, then you move downside. So let's say this is success, then no need to move downside. Okay, all right, let's focus on this. So now, what is your new point? It equals to, the function value is 0. All right, from the FP3 here, FP2 here, which is minus 7. So this is considered as failure, right? Okay, so next, kalau fail, then we move to the, again, we move to the left. So now it becomes minus 2, minus 3, right? Okay, so minus 2, minus 2, minus 3 will give you minus 8. This consider success from this one. Okay, so then success, then just proceed upside, upside, which is minus 2, minus 2. Okay, evaluation minus 2, minus 2. So your new point, new value should be minus 6. It is reduced. Then this is fail. So if fail, again move to the downside. Then your new point is minus 2, minus 4. And you will obtain minus 8 here. Since we have 8 already, minus 8 already, then this is considered as failure. Okay, clear? Then your new base point here is this one. Okay, let's just proceed with the step here. Okay, before you will kenapa stop sampai evaluation 12? Dah settle dah. Movement kita, our movement is only up until downside. Okay, for this exploration, after this we have our new base point, our new pattern move, and then we evaluate again. For each movement, we are going to stop until we complete the movement process. Okay, that's why we evaluate again. We don't stop at 12 actually, but we move to evaluation 13 by using our new base point and new pattern move. Clear now? Okay. So now identify your new base point, B4. So your B4 equals to 0 minus 3, where FB4 equals to 0. Sorry. Yeah. FB4 is 0. Okay. Sorry, this is fail. Minus 8. I put a confused. Minus 8. Sorry. This is minus 2 minus 3. This one. This one. Success. Right? Okay. Then you have your before, you have your value, then you can find your next pattern, right? Next pattern by using the B3 plus 2, B4 minus B3. Okay? Okay, up until this step, any question? So actually for this example, we are going to have about 42 evaluation. Just now we have only up to 12. Okay, we are going to have 42 evaluation in order to complete the calculation until we reach h less than 1/4. So it is long way to go. But at least now you understand the movement. Okay, you understand the how can we choose our base and our pattern. Is that clear? At least for today, that one. Anyone has question? All of you are clear until this point from 1 to 10. Where are you? Okay, let's just proceed until we reach at least half of the value, and so that you can try by your own after this. Okay. We have, okay, I'm going to stop at 10. Can we? So now P3. So P3 here is given by, let me check, okay? -3 minus 4, F P3 minus 5. Okay. Next, our exploration step now from okay, so the next evaluation evaluation 13. Okay, we start -3 minus 4. Okay. So actually this one is -2 minus 4. So our next pattern move is to the left here. Okay, this one. -3 minus 4, sorry. 3 minus 4. This is our new pattern move. So let's just start at here. Okay. -3 minus 4 to the right. About h. So what is your next point, which is -2 minus 4. So you check -2 minus 4. The function is -8, which is reduced from -5 here. Then just consider success. Okay. And then when it is success, no need to proceed to the left. Then this one to the upside. So this one become -2 minus 3. So your next evaluation 14 -3 -2 -3 will give you -8. Okay. Since we have already -8, then this is failure. Okay. Then we have again, this is failure, then we should move downside. So this is -2 minus 5. -2 minus 5. Then this one becomes -6, which is increase. Okay, then we have here failure. Okay. So stop at that. Now this value -8 is same with FB4. Right? Okay. Yes, it is success. All right. But look at this one. Of course, B1, B, our new base here, success -2 -4, all right, is not equals with -2 and -3. But, okay, but the value is same. -8 and -8. Even though B, what B here? B4. Even though B4 is not equals to B3, but FB4 equals to FB3. So we need to reduce our step length. Okay, the value is same with FB4. So again, we make an exploration step from B4. -2 -3. FB4. -2 -3. Okay. All right, clear or not? Up to this point. Oh no, it is not reduced yet. It is not reduced yet. Sorry. Okay. So now we have done with this exploration step from P2. We have our B4. We have our P3. We explore again from P3. Okay. All right. We explore again from P3. Okay. So now F -2 -4 equals to -8, which is equals to FB4. Okay, where B4 equals to -2 -3. Right? So for this case, all right, for this case, we don't explore step from P3. We should explore again at from B4. So this is what happened when you obtain the same value. Okay, so means that your next evaluation here must start again at -2 -3. So move to the right will become -1 -3. And then okay, evaluation 16 will give you -7. This is failure because it increased, right? And then to the left becomes -3 -3, which give you -3, which is failure. Okay. And then from here, we move outside. So it will become -2 -2. Evaluation 18 -2 -2 will give you -6. Still increase from the FB4 here, -8. Okay. And we move again downside. We will have -2 -4. All right. And we have -8, same, which is what? Fail. Because we have we have -8 already. So now what can we conclude? Okay, from here, all the evaluation fail. Okay, we take now all the evaluation fail. We take H equals to at least reduce up to half. Okay, understand or not? Now, from here, we evaluate, all right, we evaluate. And then we have P4, and then we have P3. We move again from P3. But for this step, okay, for this step, our new base point give the same value. So we explore it again with the same value of the previous base point, which is -2, -3. Okay, now when you explore it again from -2, -3, all value fail. Okay, all the evaluation fail. So when all the evaluation fail, then what we should do is to explore it again, but with a reduced step length. Is that clear? Understand or not? So when can we, where can we explore it? Now, with this reduced step length, we need to explore it again by using before. So we need to exploration again. Our new exploration step is from before. Okay, but our evaluation now use 0.5 as our step length. Okay, so this is our new search again. Now it reduced, the step length is reduced 0.5. So your new point should be -1.5 -3. Okay, understand or not, guys? Understand or not? So the function value here is -8.25. At least from -8, now it reduced to -8.25. This considered as a success. Okay, success, no need to the left, then just to the upside. Now it is -1.5. Yes, 2.5. This one -8, fail again. So fail, down, go downside, -1.5, -3.5. Again, -8, so fail. So your new base is this one. Okay, so your new B5. Now we have B5. When you have your new base, you should search your pattern again before and then repeat the process until at least H is less than 0.25. Is that clear? So you can try to proceed with the step, and the last evaluation should be you reach up until 42 evaluation. Okay, X1, evaluation 42, and your conclusion is up to B6. Maybe you can try by your own. And don't worry, we can discuss this again in our next class. And the minimum value is -8.375. Okay, but these are the steps. Once you obtain the same value, then what should you do? All right, you obtain all failure, then what should you do? Okay, is that clear? So I'm going to stop here. So at least you know the movement process. Okay, where can you start with the movement? And then how can you identify the failure or success? And how can you evaluate your new base point or your new pattern move and so on? Okay, you should try first. Okay, and then you can write. Of course, this need a lot of exercise. Okay, because we have a lot of calculation steps here. Okay, any question? So far so good? No question? You have class after this? Sorry, I'm taking your time. So I think we can just stop here. And don't forget those. And the attendance after this. Okay, before that, any question, guys? All of you understand? All I can see here, 8, 7, 6, 7.5, 6, 5.5. It is a good number, but you have to try it by your own after this. Okay? No question? So far, so good? No. The final answer, okay, this one. So this is the final answer. Right, so if there is no more question, I think we can stop. So for Muslim, don't forget to end our class with Suratul As and Tasbih Kifarah. Okay, don't forget to scan your attendance here. Alright, that's all guys. So please proceed with your own after this. If you have question, you can ask. Thank you everyone. Assalamualaikum.